Michael Landis with Forsyth Tech Community College. Today we're going to look at how windshield wipers operate. High speed, low speed, the park switch in them, the intermittent function in them. The vehicle that we're looking at today is a 2001 Jeep Grand Cherokee. It is computer controlled wipers. So the wipers are not hardwired, they are wired to a relay. Then the computer is going to control the relay. Our wiper switch is simply an input to the body control module. So what I have done to make this work is I've taken our cowl panel off. So I took the cowl panel off so I could access the plug for our wiper motor right here, and I have back probed 3 wires. The ones on the bottom is our signal for high and low speed, and the other one is for park. Now there is one other wire in this, and that's a ground. I'm not concerned with the ground right now because the wiper motor does work. If the wiper motor didn't work, then I would be checking the ground circuit too. And I would probably just be using a voltmeter. Today, we're going to use an oscilloscope. So here is our oscilloscope, and we're going to see what happens because it's kind of interesting what happens. Our bottom line right here at the bottom is our park switch. The next line up is low speed. The next line up is high speed. So our key is turned on, and we're going to turn the wipers on low speed and see what happens. So now what you're seeing is low speed voltage went up to 12 volts. High speed voltage actually went up to 12 volts, but you see all this static in here. Down here, if you watch, our park switch has 12 volts going to it, and intermittently it is dropping down to 0 volts. So when our wipers hit the bottom of the windshield, the voltage on the park switch will go to 0. That is an input to the BCM to tell it where the wipers are, so it can know whether or not to turn them off. Right now they are running, and if I turn the wiper switch off, you'll see they don't stop immediately, so we are now off. And they keep running, and they all die at the same time. All 3 of them went down all at one time. Let me see if I can capture that for you. Okay, so there's low speed, and I'm going to shut it off. Let me put this over to freeze. And okay, so I did capture it. So I actually when I turned the switch off, it was actually back over here. But what ended up happening is because our park switch down here is telling the PCM that we were not at park, the BCM left the relays running. It left them turned on until we got to the park position, and just as soon, the instant it saw that park voltage go to 0 volts, it turns off the relays and power stops. Now, one thing that's kind of interesting here to look at is this was on low. Notice the static in the high speed line. That is voltage that is being induced into the windings from the other set of windings. You'll see the opposite happen when we go to high speed. And if you look right after the power shuts down, notice right here when the power shuts down, there's actually a spike and then the power falls back off. That's the electromagnetic field in the wiper motor stopping. It continues to exist even though we take power away from it, and it gets induced back into the wire and it pulls the motor to a stop. But so that is induced voltage after I turned them off. So I took the voltage away, or the BCM did. It took the voltage away, and because there was still a little bit of momentum in that motor, it turned just a little bit farther, and that was enough to induce a voltage into it. And as soon as that died to nothing, the motor actually stops. So we took the power away here, but this second bump, that's where you actually see the motor stop. So we're going to turn this back on, and let's look at high speed, see what happens. Here's low speed. Notice the static up here in the top line. When I go to high speed, you'll see they just change places. Now the static in the top line, which is our high speed voltage, is steady, but what's below it is being induced by the motor. That's just what's being induced by the windings of the motor. And if I turn this all the way off, just like I did before, you'll see what happens as soon as I turn it off. It switched from high speed to low speed and brought it down to the bottom of the wipers. Let me see if I can catch that switch, and you'll be able to see. Now we're back up and running. So if I turn it on high speed, how fast is this running? 1 second, hang on. Okay, I was able to catch it. Right here is where I turned the switch off. Notice we were on high speed. As soon as I turned the switch off, the high speed relay turned off, and it turned on the low speed relay to bring it all the way to a stop, and then it shut off. So if our park switch never went to 0 volts, our wipers would not shut off. They would run because we have the relays on, but if it never goes to 0 volts, we will not shut it down. And the relays actually come on first, and then you'll finally see it move. These happen so fast, they almost look simultaneous. I'm looking at this kind of slow. I'm only on a 1 second sweep all the way across the screen, but it's fast enough that you can actually see when I turn it on. You'll be able to see the relays jump. Let me put the camera down, I'll turn it on, that way I can use 2 hands, and we'll see the relay jump. Okay, so I turned it on low, and here you can see power came out to the motor from the relay because I turned the switch on. So the BCM grounded the low speed relay to start the motor running, and this is how fast it happened. I turned it all the way to high, so you can see in this display right here it actually switches over to high. So I was turning the switch, it hit the low first. You can see that come up. I've got a nice clean line. I've got induced voltage in the other side in the high speed, and there was a slight delay before the motor actually moved far enough to take it off of park, and that was when the motor actually was spinning. Here the motor is actually turning, Here we're just building up the magnetic field to get it going. And you can actually see the voltage kind of ramping up as that magnetic field builds. Now, when I finally hit high speed over here, you can see the line smooth out. Or we went from low speed to high speed because you see where the induced voltage is different. So that's how this works. Now if I put this on intermittent, this type of system, the way it works, I have it on intermittent right now, and we'll just watch it here for a second. I'll turn it on so it cycles on and off. And what you'll be able to see is it looks like everything happens at the same time. They turn on, they turn off. They turn on, they turn off. And so the way this system is working is if the